Good afternoon, everyone. I am your T. Vidushi, and today is the problem solving session 5. So, what do you understand by atomic spectroscopy? It is the study of the electromagnetic radiation absorbed and emitted by atoms. So, hydrogen atom, there are several spectral series that are Lyman series, Balmer, Paschen, Brackett, Fund, and the Humphrey series. This series we already discussed in a previous session. So firstly, we will discuss about the Lyman series. These series are obtained in the UV region, and in this series the transition is from the first orbit to the higher orbit, that is N1 will be 1 and N2 will be 2, 3 and so on. So the next series are the Balmer series. These series are obtained in the visible region, and here the transition is from the second orbit to the higher orbit. Therefore N1 will be 2 and N2 will be 3 and so on. The third series is the Paschen series. These series are obtained in the near IR, and here the transition is from the third orbit to the higher orbit. Therefore N1 will be 3 and N2 will be 4, 5 and so on. The next series is the Beckett series. In this series the transition is from the fourth orbit, and this series is obtained in the mid IR region. While if we look at the front series, these series are obtained in the far IR region, and the transition is from the fifth orbit to the high orbit. So on the left hand side, if you look about the atomic spectra, so basically the atomic spectra are also called as the fingerprints of an atom, because it can differentiate between different atoms, such as if we look upon hydrogen, neon and iron, these have different atomic spectra, and therefore these are also called as line emission spectra. So these are different for different atoms, therefore it is fingerprint of an atom. Now if we look on the questions, so first question is, find out the minimum energy required to take out only one electron from the ground state of lithium. Whether it is 13.6, 122.4, 25.3 or 67.9. So here we are talking about lithium. So we know that for the lithium atomic number is 3. And to calculate the minimum energy, the formula is 13.6 Z square. So substitute the Z value, that is atomic number value. So it will be 13.6 into 9, that turns out to be 122.4 electron volt. So moving to the second question, calculate the wavelength of a photon emitted when an electron in hydrogen atoms makes a transition from n equals to 2 to n equals to 1. So what will be the answer for this? Basically we have to calculate the wavelength, and the transitions are given that n is 2 to n equals to 1. So we already discussed a lot about this formula, that 1 upon wavelength is equals to r 1 upon n1 square minus 1 upon n2 square. So just we have to calculate the wavelength. So substitute the value of r. R is the Rydberg constant, whose value is 109677 centimeter inverse, and n1 will be 1 and n2 will be 2. So the answer will be 2.27 into 10 raised to 5 minus 6 centimeters. So I will erase this. So moving to the next question. If an electron makes a transition from the seventh excited state to the second state in an hydrogen atom, we have to find the number of spectral lines. And we know the formula for the spectral lines. Its formula is n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. So what will the value of n2 and n1 from this question? Now if we will look upon, they're telling seventh excited state and second state. So second state will be your n1, and what about n2? It will not be 7. Why? It's seventh excited state. So you know there is ground state, then there are excited states. So in that sense, there are 7 excited states like AS2, 3, 4, 5, 6. So total will be 7 plus 1, that will be 8. So n2 will be 8 and n1 you know it's 2. So substitute the value. It will be 6 into and 7 by 2, that is 42 by 2, that is 21. So the number of spectral lines will be 21. Is it clear? Now the next question. The wavelength of a Lyman series lies in visible UV, radio waves or IR. So basically what was the Lyman series? It was the series in which transition is from the first orbit. Therefore n1 will be 1 and n2 will be 2, 3 so on, and this is generally obtained in the UV region. So the answer is ultraviolet region. So moving to the next question. The energy of an electron in a hydrogenic atom with nuclear charge Z varies as Z, Z square, 1 by Z, 1 by Z square. It will be Z square. This will be the answer. Because it is equals to 13.6 Z square, we already discussed. And for hydrogen it will be 1, so it will be equal to 13.6 Z square. Now, the potassium salts are placed in a Bunsen frame to obtain the line spectra. The color of the light emitted is yellow, violet, green or white. So you have to tell the color of the emitted light for potassium salts. And also tell me about sodium salts. So what will the light emitted in case of potassium as well as in case of sodium? So for potassium it will be violet and for sodium it will be yellow. So basically the color of the light emitted, it depends upon the nature of the substance. For example, sodium and the salts emit yellow light while potassium gives violet light. Now the next question is, a alpha line of a Balmer series corresponds to shortest wavelength with n2 equals to 2, longest wavelength with n2 equals to 2, longest wavelength with n2 equals to 3 or shortest wavelength with n2 equals to 3. So basically what do you understand by alpha line? Basically alpha line is the first line. Now they're talking about Balmer series, so it's the first line of the Balmer series. And your Balmer series are those which transitions from the second orbit. So for the first line, n1 will be 2 and n2 will be 3. Now the next question. The wavelength of a certain line in Palmer series is 4341 Armstrong. To what value of n does it correspond? So you have to calculate the value of n. So you know this formula. So if you for Balmer series n1 will be 2. So substitute the value of 2. In this way you can also write. So now if you will substitute the value of wavelength and the Rydberg's constant, and it is in Armstrong, so you will convert into meter. Or just convert it into centimeter. So at final it will be n square will be 1 upon 0.04. So it comes out to be 25. So n will be root 25, that is 5. So the answer will be 5. Because for Balmer series n1 is 2. Now I will erase it. So the next question, calculate the wavelength of the first line and the series limit for the Lyman series for hydrogen. So what do you understand by the first line or the series limit? So if you look about the first line, it means wavelength should be high, or simply you can say the energy difference between them should be maximum. So when it will be maximum, then n2 will be infinity. So now you have to calculate the wavelength, and the formula for wavelength. 1 by wavelength is equals to Rydberg constant 1 upon n1 square minus 1 upon n2 square. And here they're talking about Lyman series, and Lyman series, the transition is from the first orbit, therefore the n1 will be 1. And the value of RH also. It is 109678. It's already given. It's 1 square minus 1 upon infinity square. So it would be sorry, just a second. We are talking the first line, like the Lyman series, and one is 1 here, 2, 3. For the first line we are talking about the so in that case the energy difference would be minimum. So therefore N2 will be 2. So energy difference will be minimum when N2 is 2. But maximum will take in the series limit. So it will be 2 square. So the wavelength turns out to be 1215.7 into 10 raised to power minus 8 centimeter. Or if you can convert into Armstrong, it will into 5215.7 Armstrong. So now if you look upon the series limit means shortest wavelength. So for that, like instead of longest, select shortest wavelength, and here the energy difference should be maximum. Therefore the value of N2 will be infinity. So if you have to calculate the wavelength, so you know this formula, again put N2 as infinity, so the answer will be 9.117 into 10 raised to power minus 6 centimeter, or 911.7 Armstrong. So just remember, for the first line the energy difference is minimum. So if it is minimum, the wavelength should be higher, and the series limit the energy difference is maximum, so the wavelength will be shorter. And when the energy difference is minimum, when N2 is 2, and when it will be maximum, it will be infinity. So the next question is calculate the maximum wavelength of Balmer series in the hydrogen spectra and calculate the corresponding wave number. So similarly here you have to calculate the wavelength maximum wavelength you have to calculate for the Balmer series. So R is given, it's 1.097 into 10 raised to power 7 meter inverse. It will be 2 sphere minus 1.3 sphere. Now see, they are talking about maximum wavelength. Maximum wavelength means energy difference should be minimum. And they are talking about Balmer series. Balmer means N1 is 2. So when energy difference will be minimum, that means N2 will be 3. So after solving it, the wavelength turns out to be 6.56 into 10 raised to power minus 7 meter. Also, they are telling you calculate the wave number. So what's wave number? Wave number is reciprocal of wavelength. So if you will substitute the value, then the wave number will be 0.152 into 10 raised to power 7 meter inverse. Is it clear? As in the question, they were asking about the maximum wavelength. And you know that energy is inversely proportional to wavelength, so maximum wavelength corresponds to the minimum energy gap. And they're talking about the Balmer series, and you know that in Balmer series the transition is from the second orbit, so N1 will be 2, and if you look upon N1 2, and then when the energy gap is minimum, when N2 is 3, therefore you take N2 as 3 and then you calculate the wavelength. They have also asked how to calculate the wave number. You know the wave number is reciprocal of wavelength, so in that sense you can calculate the wave number by putting or substituting the value of wavelength. Now I will erase it. Now the next question is, according to the Bohr atomic model, the radius of the orbit is directly proportional to n square 1 by n square 1 by n or n. So it is n square. Now the next question is, the difference in the angular momentum of revolving electron in third to that of sixth orbit is. Now what is angular momentum? Angular momentum, it's nh by 2 pi. So what's n? N is the orbit. So they are okay, third orbit to sixth orbit. And then we have to calculate the difference. So it will be 6h upon 2 pi minus 3h upon 2 pi. Just a second. So it will be 3h upon 2 pi. That is 1.5 h upon 5. Now the next question. The angular momentum of an electron in a third Bohr orbit is. Now third means n is 3. So angular momentum, it's nh by 2 pi. So n is 3. So h, substitute the value of h. So after solving, the answer will be 3.1 into 10 raised to the minus 34 kg meter square per second. So 21 into 10 raised to the minus. So this is the value of angular momentum. Now I will erase it. Now basically we have to know what do you understand by term symbols. So the different electronic states of an atom or ion are described by L and S in the form of term symbol. One term symbol can describe one or more microstates with the same energy. The term symbol indicates the total orbital angular momentum, that is L, and the multiplicity 2s plus 1 of the state. And 2s plus 1 is the multiplicity, and it can also be equal to the total number of unpaired electrons plus 1. So as term symbol, it is 2s plus 1 L, where this will be the multiplicity and s is your spin. So suppose if in a p orbital there is 2 unpaired electrons. So for one unpaired electron the spin is half. So there are 2 unpaired electrons, so half plus half, spin will be total 1. And suppose if there are paired electrons, then the spin will be 0, because plus half and minus half, it will be 0. So here 2s plus 1 the spin multiplicity. L is the total orbital angular momentum. And how you will calculate L? If the value of L is 0, then it corresponds to S. If it is 1, then it corresponds to P. If it is 2, then D, and 3, then it is F. These are the values of total orbital angular momentum. Now you can also write the ground state term symbol 2s1lj. What is J? And how can you calculate the J? Suppose if you're talking about the p subshell and you know how much electrons it can accommodate, total the p electrons can accommodate 6 electrons, and there are more than half filled electrons, as there are 4 unfilled electrons and it can accommodate 6, so it's more than half. So in that sense the value of J will be L plus S. If there is less than half filled, then the value of J turns out to be L minus S. J equals to L minus S. And suppose if it is exactly half filled, like here, then J value will be equal to the S value. These things we have to remember. So for calculate the term symbol, S is your multiplicity, 2s plus 1 is your spin multiplicity, L is the total orbital angular momentum, and just remember that if L is 0 it will be S, if it is 1 then P, for D it's 2, and for F it is 3. Thirdly, how you will calculate the J? If the in a subshell it is more than half filled, then L plus S. If it is less than half filled, then L minus S. And if it is exactly half filled, then use L. J equals to S. Now we will solve some questions related to this. What is the atomic term symbol for a helium atom with electronic configuration 1s2? So what's 1s2? This is like this. So you know 2s plus 1 Lj. So what's the spin? So it's half minus half, the total spin will be 0. So 2s plus 1, 2 into 0 plus 1, that is 1. So the spin multiplicity is 1. What's L? L, like you know, it's 0, then it's S, 1, it's P. So for S, it's 1s2, so S, it will be 0, that means S, so it will be 1 S. And what about J? It will be L plus S, so 0 plus 1, so it will be L plus S. L is 0 and S is also 0, so 0 0 is 0 total. Just a second. So it will be 1 and 0. As L is also 0, S is also 0. Now to calculate total number of energy levels contained in term 3L. So how you will calculate it? Now you have to calculate the total number of energy levels. So there is one formula, just remember it, 2s plus 1 and 2l plus 1. So now you see it's 3f, and you know the value of S and L. 3 means the spin multiplicity is 3. So in this way you can calculate the value of S. And what is L? It's F. The total orbital angular momentum is F. So when it is F, when the value of L is 3, so L will be 3. Now substitute the value 2 into 1 plus 1 multiplied by 2 into 3 plus 1. So it will be 3 multiplied by 6, 7. So it will be 21. So total of energy levels will be 21. Is it clear? Basically what we have done here, here it's 3F. And what's 3? 3, it's a spin multiplicity, and F is the total orbital angular momentum. And if L is 3, then it's F. And by the spin multiplicity, you can calculate the value of S. So substitute in the equation, like energy levels are equal to 2s plus 1 into 2l plus 1. Therefore, you will get the answer by substituting the value of S and L. So there will be total 21 energy levels. Now in the next question, you have to calculate the possible term symbols for 1s2, 2s2, 2p1 electronic configuration and what is the ground state. So see, you have to think about 2p1. 2p1 means there are only one unpaired electrons. So the spin will be half. If you calculate the multiplicity, it will be 2 into half plus 1, that will be 2. So now S will be 2, and what about L? L can be 0 or 1 because they are asking the possible term symbols. So for 2, when is L 0? When is S? So it can be 2S, and if L is 1, it can be P. So 2P. So now these are the possible 2S and 2P are the possible term symbols. Now you have to know which is the ground state. So how you will choose between these two, as these two have the same same multiplicity, like that is 2. So you will take higher value of L. So higher value of L is in P, na it's 1, as in S it is 0. So you will take 2P. So the ground state will be 2P here. And what with the possible term symbols, it will be 2S and 2P. If you have been asked for possible term symbols, where you have to add different values of L, and for each value you have to calculate the term symbol. And when they're asking specifically about the out of these which will be the ground state, so choose according to spin multiplicity and the L values. If whosoever will have higher L value will be the ground state. Now the next question is find the term symbol for the following cases. Now term symbol is S plus 1 L. So now the S value is already given, it's 0. If you solve in the first case, it is 1 and L is 0. Now you know that when L is 0, it corresponds to S. When it's 1, it's P. For 2, it's D. For 3, it's L. Now if they are talking L is 0, so it means S. So answer will be 1S. Now if L is 0 and S is half, how you will solve it? 2S plus 1. So S is half plus 1. So it will be 2. L is 0. So it is 2S. For the next, L is 1 and S is 1. So what will be the answer? it will be 3, and when L is 1 it's P, so it will be 3P. Now I will erase it. Now for this fourth part, L is 2 and S is 3 by 2. So 2S plus 1, S is 4, 2S plus 1 is 4, and L is 2. 2 corresponds to D, so it will be 4D. Now the fifth part, L is 3 and S is 2. So 2S plus 1, it will be 2 into 2 plus 1, that is 5, and when L is 3 it's 3. For 3 it's F, so it will be 5F. So now we have to calculate the ground state term for the free ion with electronic configuration D1, D3, D5, D7, D8, D10 and D9. So how you will calculate it? So let's first talk about the D1 system. Like for the D1 system, here 1 indicates that there is only one unpaired electron. And you know in D we can accumulate 10 electrons. 5. There is only 1. 0, minus 1, minus 2, 1 and 2. So how you calculate here? Now we know you have to calculate 2s plus 1 Lj. So 2s plus 1. So what's S here? There is one unpaired electron, so S is half. So 2 into half plus 1, it will be 2. And what will be the L? How you will calculate L here? It's 2 here into how many electrons are there? 1. And in this there's nothing filled, so it will be 21, that is 2. And if you look, when is L2? It corresponds to D. So it will be 2. L is D. Now you want to know the value of J. And if you look upon D1, it is less than half filled as only one unfilled electron is there. So we discussed in the previous slides that for less than half filled J is L minus S. And you know L is 2 and S is half. So it will be 3 by 2. So the answer will be 3 by 2. Is it clear? This was for the D1. Now we will solve for the D3 system. So what about D3 system? D3 means there are 3 unpaired electrons. So just fill the 3 unpaired electrons in the shell, D subshell, and make sure like you're filling the electrons properly. Suppose there are 7 electrons, so you have to fill 1, 2, 3, 4, 5, 6 and 7. You don't have to fill like this. Yeah, this is empty now. So first electron you should fill in every orbital, then fill the next. Each orbital first should be singly occupied, then you have to pair it up. So this is not the right way, this is the right way. And why it is not erasing? So for the D3 system, now 2s plus 1 and j, this we have to calculate. So what will the s? You know, for one unpaired electron it's half, so there are total 3 unpaired electrons, so it will be 3 by 2. So 2s plus 1 you have to calculate, it will be 2 into 3 by 2 plus 1, that is 4. And how you will calculate the value L? It will be 2 into 1 plus 1 into 1 plus 0 into 1. 2 into 1 plus 1 into 1 plus 0 into 1. So it will be 3. So if you look, so 3 corresponds to F. So now you know it's 4F. And what about J? It's less than half field. So J is L minus S. L is 3, S is 3 by 2. So the answer will be 3 by 2. 4F 3 by 2. Why it is 3 by 2? Just take the LCM. 6 minus 3. That sense it's 3 by 2. So for D3 the ground state term will be 4F 3 by 2. So I will erase it. Now we will solve for the D5 system. D5 means there are 5 unpaired electrons. It's exactly half filled. So for S, what will the S? There are 5 unpaired electrons. So for one unpaired electron, it's half. So spin will be 5 by 2. So 2s plus 1, 2 into 5 by 2 plus 1, it will be 6. For the multiplicity, and what will the value of L? 2 into 1 plus 1 into 1 plus 0 into 1 plus minus 1 into 1 plus minus 2 into 1. It will be 0. Just remember, if the electrons are half filled, exactly half filled, then L is 0. So it will cancel out. So what value of L? So what is orbital and momentum? It will be S. For L is 0, 1, 2, corresponds to S, P, D. So for 0 it's S. Now it will be 6. It will be 6S. And what will the value of J? What will the value of J? Is exactly half filled. So J is S. And S is 5 by 2. So J will be 5 by 2. So the answer will be 6S 5 by 2. Now just tell me for the D7 system, what will the answer? For the D7 system. Seven means there are 7 unpaired electrons. Seven means there are 7 unpaired electrons. So just draw 7 unpaired electrons. So what will the value of S? So total S for this will be 0. So the 3, it will be 3 by 2. Like for S for the paired one, it will be 0 now. So there are 3 unpaired electrons that will be left. So for each it's half. So for 3 into half, it's 3 by 2. So for the multiplicity, it will be 2s plus 1, that is 2 into 3 by 2 plus 1, that will be 4. And what about L? L will be 3. By 3, it will be 0 into 1 plus minus 1 into 1 plus minus 2 into 1, that turns out to be 3. And for 3, it means it corresponds to F. So it is 4F. Now, in D, it can accommodate maximum 10 electrons. So there are 7. So it is more than half filled. So we'll use the formula J equals to L plus S. And what's L here? L is 3. And what's S? S is 3 by 2. So it will be 9 by 2. So the answer will be 4F 9 by 2. Now we will solve for the D8 system. like if you look DH system, there are 8 unpaired electrons, so fill it. So S will be 1, half into half plus half, 1, 2s plus 1, it will be 3. And what about L? L, it will be again 3 by minus 2 plus into 1 plus minus 1 into 1, it will be 3. So it is 3f. And what about J? It is more than half filled. So L plus S, 3 plus 1, it's 4. So it will be 3f4. Now we will solve for the D10 system. D9 is very simple. It's completely filled. So S is 0 because all are paired. 2s plus 1. It will be 1. L, you know, is 0. So 1s. And what about J? L plus S. 0. 0 plus 0. 0. So it will be 1s 0. So but for the ground state term for the D9 system, now for the D9 system, this last part is remaining. D9 means that there are 9 unpaired electrons. So S is half. All are paired, only one unpaired electron is there. 2s plus 1. 2. And what will be the L? L will be 0, minus 1, minus 2, 1. L will be 2. Because for paired it's 0, it will be 2. So 2 corresponds to D. So it's 2D. And you know it's more than half filled. So it will be J equals to J equals to L plus S. L is 2, S is half. So it will be 5 by 2. So 2D 5 by 2. Is it clear? Now what do you understand by Laguerre polynomial? Now we will solve some questions related to the Laguerre polynomial. So basically what you have to remember for the Laguerre polynomial, it is denoted by LPQ so it is equals to d by dx raised to power p LQX, and this LQX you can calculate EX d by dx raised to power q e minus x and x power q. So for the first we have to calculate Laguerre polynomial L13 is equal to. So for before that we will solve this one. So The second question is, what will be the Lagrange polynomial associated with 1s1 of the hydrogen atom? We are talking about 1s1. And just remember this P and Q. Here P equals to 2L plus 1 and Q corresponds to N plus L. So for 1s1, what will the P and Q? L is 0 and N is 1. Like here, this value corresponds to N and it's S, so L is 0. So you will calculate the value of P. It's 2L plus 1, that is 2 into 0 plus 1, that is 1. And what about Q? Q is N plus L, N is 1, L is 0, so it will be 1. So both Q and P are 1 respectively. So basically you have to calculate this value L11. This you have to calculate. So how you will calculate it? Before that, I will once again repeat. Lagrange polynomial, we are calculating this value. And for this value to calculate, we should know what's P and Q. P can be 2L plus 1 and Q can be L plus L. We are talking about the 1s system. So now this one indicates the N, the number of the orbit. So if you solve the P value, it's 2L plus 1. You know when L value is 0, then it corresponds to S. So it's 1, so it is S. So 2 into 0 plus 1, it's 1. And what about Q? Q is N plus L. N you know it's 1, L is 0. So Q also comes out to be 1. So now you have to calculate the Lagrange polynomial for this term. This you have to calculate. Now you know this Lagrange polynomial, it corresponds to d by dx raised to power p. So what's p? P is 1. So 1 we don't need to write. LQX. So for that we need to know, to differentiation of LQX, we should know what is LQX. LQ. Q you also know it's 1. So firstly we will solve this. It is LQX. It is EX. Differentiation d by dx raised to power q. It's already 1, so no need to write. Yes. So basically EX is as it is. Now you have to differentiate. There are two terms. So how you will differentiate? Differentiate first term and keep the second term constant. Then plus it and then keep the first term constant, differentiate second term. So e minus x. So what's the differentiation? It will be e minus x. Differentiation of second term. Second term as it is plus. Now this term will be constant and you have to differentiate the second term. So it will be ex, e minus x, x plus e minus x into 1. Dx is 1 and ex into e minus x is 1. So it will be minus x plus 1. So now you know the value of LQX. So for value of LPQX, put this value LQX in this equation. So what it will be? It will be L11x is equals to d by dx L1x. It will be L11x equals to d by dx. What was the value? It comes out to minus x plus 1. So the differentiation of x, it's 1 only. The answer will be minus 1. So the Lagrange polynomial associated with the oneness will be 1. That is minus 1. I will repeat this again. So basically you have to calculate the Lagrange polynomial. This term. Lagrange polynomial is LPQX that you have to calculate. So the Lagrange polynomial is equals to the d by dx raised to power p LQX. And you should know what's LQX. LQX is equals to EX d by dx raised to power q e minus x ki power x raised to power q. So here what is p and q? For p you can write it as 2l plus 1 and for q it can be n plus l. So they were asking about for the oneness 1. So here this denotes the n value, and you know when L value is S, when L is 0. So that means L is 0 and N is 1. So substitute the value, then you can find out the P value. It will be 2 into 0 plus 1, that is 1. And for the Q value, it's N plus L, that is N is 1 and L is 0. So it turns out to be 1. So P and Q both are 1. So you have to calculate this polynomial LPQ. PQ are 1, so L11x that you have to calculate. Now you know this equation L11x equal to d by dx raised to power p. P is 1 here. So you may write 1 or there is no need to write. And then LQX. LQ is also 1. So for that you need to firstly solve the value of LQX. So for LQX, Q is 1, so L1x equal to EX d by dx e minus x into x ki power 1. It's 1. So EX is EX, differentiation of e minus x and x 1. So there are two terms. So how you will solve it? So firstly you will differentiate this term and keep this term constant, then add, then keep this term constant and differentiate the second term. So differentiation of e minus x is minus e minus x, second term constant, plus first term as it is, and differentiation of second term. Second term is x, so it is dx by dx. Now after this, ex into e minus x is 1. So it will be minus x plus 1 because dx by dx is 1. So for the LQ, it will be minus x plus 1. So now you get to know about the LQ polynomial. But you have to calculate the Lagrange polynomial, that LPQX. So substitute the value of LQX here. Then after that, it will be d by dx L1x. So d by dx L1x is the LQX, that is minus x plus 1. So after solving it for the differentiation of minus x plus 1, it will be minus 1 only. So the answer is minus 1. So suppose if we have to calculate for the different term, suppose it is L to 1, where P is 1 and Q is 2. This we have to calculate. So P is 1, Q is 2. So how you will calculate for this? Basically, you know LPQX is equals to, why it is not working, d by dx P raised to power P LQX. And what's LQX? It is EX d by dx raised to power Q E minus x raised to power Q. So substitute the value of P and Q. It is L 1 2x equals to d by dx L to x. So for that you should know value of L to x. It will be E x d by dx Q is 2. So it is like this. So there is double differentiation here. Ex double differentiation E minus x raised to power 2. So how you will solve it? So it will be Ex. First time you will differentiate minus E minus x square as it is, plus E minus x, differentiation of x square is 2x. Now it is, maybe I will erase it and do it again. Why it is not coming? Suppose you have to calculate this. Here P is 1 and Q is 2. So for this, how you will calculate? So you know this formula, L PQX is equals to d by dx raised to power P LQX, and you know LQX is equals to EX d by dx raised to power Q E minus x power Q. This you already know. So firstly, substitute value of P and Q in the above equation. So basically firstly we calculate the LQX, that is L2x. It is equal to EX d by dx Q is 2 E minus x Q is 2. So it's double differentiation. So differentiate for the first time. E minus x, it minus E minus x square plus E minus x 2x. So now it will be EX. Now second time differentiation, it will be E minus x square constant plus E minus E as this differentiation to x square is 2x plus, now you will differentiate this term, it will be minus e minus x 2x as it is plus e minus x as it is. Differentiation of 2x is 2. So it will be ex e minus x x square minus 4x e minus x plus 2e minus x. So you know that ex into e minus x is 1. So it will be x square minus 4x plus 2. This is value for the q term. Now for the p Lagrange polynomial L2x, it is equal to d by dx of L2x. So d by dx of x square minus 4x plus 2, it will be 2x minus 4. So this will be the value for the L21x. Maybe I will repeat it so that it will be better clear. Suppose we have to calculate the Lagrange polynomial for this term L21x, where p is 1 and q is 2. So for the Lagrange polynomial there are two formulas. So first it's d by dx raised to power p multiplied by lq into x. But lqx is ex d by dx raised to power q e minus x x raised to power q. So now substitute the value of p and q here. So it will be L21x equals to d by dx 1 L2x. Now you need to know the value of L2x for differentiation. So for L2x the formula is ex d by dx, as q was 2, so it is 2 e minus x x is equal to 2. Here 2 is also, as q is 2. So how you will solve this? It's double differentiation. So ex is as it is. So differentiation, what's differentiation of e minus x and x cube? There are two terms. So firstly we will differentiate this term and keep the second term constant, then add and keep this term constant and differentiate the second term. So differentiation of e minus x is minus e minus x square as it is, plus then e minus x is as it is and x square is differentiated, so it is 2x. Now again there are two terms here and here. Now we will differentiate differently. So ex is ex. Now differentiation first this term. So differentiation of minus e minus x is e minus x. Just remember, differentiation of e minus x is minus e minus x, and opposite for minus e minus x is e minus x. So now here it's minus e minus x, so it's e minus x. Second term is x square, so it is constant, plus now first term as it is, and differentiation of x square is 2x, plus this was the term. Now for the second term, e minus x into 2x. So e minus x differentiation is minus e minus x 2x, plus e minus x is as it is, differentiation of 2x is 2. So how you will solve? Ex is as it is, so it is e minus x x square minus, it will be add, so it will be 4x e minus x plus 2 e minus x, and you know ex into e minus x is 1. So it will be x square minus 4x plus 2. So this was the value for the LQX, that is L2x. Now you want to know the Lagrange polynomial, that is L12x. So it is differentiation of L2x. So what's L2x? It's x square minus 4x plus 2. So differentiation of x square is 2x, and for 4x minus 4x it's minus 4, 2 is constant. So the answer will be 2x minus 4. This one. Is it clear? So now we solve this question. Lagrange polynomial L1 by 3 is equal to. So we have to solve for this. So just tell me what will be the answer. So basically we have to calculate for L1 3. Here P is 1 and Q is 3. So what will be the value of LP? Qx. So it will be L1 3x. It will be equal to d by dx. P was 1 and 3x. So now you will know L3x. It is equal to Px d by dx raised to power 3 e minus x raised to power 3. So we will solve the first L3x one. This one we will solve first. So L3x is equals to ex is as it is. Now it is 3 time differentiation. So for the first time, what it will be? It is e minus x cube. So for differentiation of e minus x, it is minus e minus x cube. It is x cube plus e minus x as it is. Differentiation of x cube is 3x cube. Now we do again ex. One more differentiation of these are 2 terms. So for minus e minus x, it's e minus x cube as it is, plus e minus x as it is. Differentiation of x cube is x cube, plus now we look upon this term. Differentiation of e minus x is minus e minus x 3x cube as it is, plus e minus x as it is. Differentiation of 3x cube is 6x. So now again it's ex. Now we will again differentiate this term, this term, this term and this term. So it will be minus e minus x cube plus e minus x 3x squared plus minus e minus x, it's e minus x 3x squared plus minus e minus x dot 3 to 6x. Now this term plus e minus x 3x square plus e minus e minus x 6x plus minus e minus x 6x plus e minus x dot 6 ex minus 3x square plus e minus as it is 3x square plus minus e minus x 3x square plus minus e 6x plus for this term it is be e minus x 3x square plus minus e minus x 6x plus for this term it is minus e minus x 6x plus e minus 6. Yeah. Keep. So it was, now you know ex into minus into ex into e minus x is 1. So it will be, or you can just simplify it as ex minus e minus x x cube plus 9 e minus x x square minus 18 x e minus x plus 6x e minus x. So you know the ex into e minus x is 1, so it will be minus x cube plus 9x cube minus 18x plus 16 6. So L31x will be equal to differentiation of minus x cube plus 9x square minus 18x plus 6. So for the minus x cube it's minus 3x square plus 18x minus 18. It's like this. So see, it's minus 3x square plus 18x minus 18. So what we have done for this, for L31x, for L31x, P1 is Q, P1, P is 1 and Q is 3. So L31x will be equal to d by dx raised to power P. P is 1 into LQX, Q is 3. So it will be L3x. Now you need to know what is L3x. So L3x will be equal to Ex d by dx raised to power Q. Q is 3. E minus x into x power 3. Q. So Q is 3. So it will be L3x equal to Ex. Now you have to differentiate it. So there are two terms. First differentiate the first term, keep the second term constant, plus differentiate the second term and keep the first term constant. So this is what we have done here. It will be minus e minus x x cube plus e minus x as it is, and differentiation of x cube is 3x cube. Now it's double differentiation, so you have to double differentiate 2 times more. So ex is as it is, differentiation of this term and this term. For first term, minus e minus x into x cube, so it will be e minus x x cube plus e minus x 3x cube. Now for the second term, e minus x is minus e minus x 3x square as it is, plus e minus x is as it is, differentiation of 3x square is 6x. So for now you have to differentiate 4 terms. So ex is as it is, differentiation of e minus x x cube first. So it is minus e minus x x cube as it is, plus e minus x as it is, differentiation of x cube is 3x cube. Now for the second term, it's minus e minus x. So differentiation is e minus x 3x square as it is, plus e minus x minus e minus x as it is, differentiation of 3x square is 6x, plus for the third term, that is minus e minus x 3x square. it is e minus x 3x square plus minus e minus x into 6x. Now for the fourth term, it will be minus e minus x 6x plus e minus x into 6. So then after solving it, it comes out to be minus x cube plus 9x cube minus 18x plus 6. This was the value of the LQX, that is L3x. Now you want the value of Laguerre polynomial LPQX. So it's L31x, the differentiation of above 1 will give you the value. So it's minus x cube plus 9x cube minus 18x plus 6. The differentiation of minus x cube is minus 3x cube. For 9x square it's 18x. For minus 18x it's minus 18. This will be your value. So now that's all for today. So basically what we have done in today's class. So firstly we discuss about atomic spectroscopy. Atomic spectroscopy. So these atomic spectroscopy are the fingerprints of an atom. Then we discussed about the spectral series of hydrogen atom, that there are different spectral series that are Lyman, Balmer, Paschen, Brackett and the Funt series, and another one is also there, that is Humphrey series. So basically these series are obtained in different regions like UV, IR, visible. So first series is the Lyman series that are obtained in the UV region, and in this the transitions from the first orbit. Then comes your Balmer series that are obtained in the visible region. Then comes your Paschen series that are obtained in the near IR. Then Brackett that was obtained in the mid IR. Then that was the Funt series that was obtained in the far IR. Then we talked about how you calculate the energy for the lithium ground state of lithium ion. You know, lithium is 3 atomic number, has 3 atomic numbers, so it is 30.6 into Z cube. Then we discuss how to calculate the photon. How to calculate the photons wavelength. So 1 by wavelength is equals to R into 1 upon n1 square minus 1 upon n2 square. Then we discussed how you can calculate the spectral lines. Like these formulas we have to remember. Like for spectral lines, it is n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. And for the wavelength, it was 1 by wavelength is equals to R 1 upon n1 square minus 1 upon n2 square. For the above one, it was 30.6 into Z square. These three formulas you have to remember, as n was 1 for the electron. Then you should know that the color of the light emitted, if it is potassium, then it corresponds to violet, and for sodium it is yellow. Then we discuss what do you understand by alpha line. So basically alpha line is the first line. Then this is all about the wavelength. Then what's angular momentum? Angular momentum is nh by 2 pi, and n is the number of orbits. So here like it's third and sixth orbit, so n1 will be 3 and 6 respectively. H, you know, H is 6.6 into 10 raised to the minus 34. Then we discuss about the term symbols. Like term symbols, there is 2s plus 1 L J. So basically what is S? S is your spin. So basically if there are only one unpaired electron like this, so spin is half. If there is paired, then spin is 0. Why? Because for one it's half, for another one it's minus half. So half plus minus half is 0. Then what's 2s plus 1? It is your multiplicity. And L is your total orbital angular momentum. So L can have different values. If it is 0, then it corresponds to S. If it is 1, then it corresponds to P. If it is 2, then it corresponds to D, and F for 3. And what J can be calculated as, if suppose in D there are 10 electrons that can be accommodated. Total electrons are 10, and there are 4 unpaired electrons. So it's less than half filled. So in that case, you will take J value as L minus S. And suppose if in the subshell there are more than half filled electrons, suppose there are 7 unpaired electrons, then you will take value of J as L plus S. And suppose if in the subshell there are only half filled electrons, like exactly half. So like if for D you can accommodate 10 electrons total, so there are 5. So it's exactly half filled. So in that case, the whatsoever the value of spin, that is S, will be the value of J. So in that case, J will be equal to the S value. So that's how we solve the value for the term symbols for different systems. But this slight thing that you have to remember for the ground set terms for the free ions, like for D1 to D9 system, then how you calculate the value of L. Basically, if there is D3 system, so for what will the value of L? So it will 2 into 1, like there are 1 electrons, 1 into 1 plus 0 into 1. So it will come out to be 3. So in this manner, you calculate the value of L for these systems. So for ground state, you have to calculate the value of spin multiplicity, J value, and total orbital angular momentum. Then what do you understand by the Laguerre polynomial? So basically the Laguerre polynomial LPQX, that you have to calculate out. These values. So there is a formula for LPQX, that is LPQX is equals to D by dx raised to power p LQX, and what's LQX? It will be equal to EX d by dx raised to power q e minus x into x raised to power q. So we have calculated for the 3 systems. Basically, how we calculate for the first system, like if we have to calculate for the 1s1. So for the 1s1, we should know the value of p and q. P is equal to the 2l plus 1, q is equals to the n plus l. So basically, how you can determine the value of L, you know, here it is S. So L is 0, it corresponds to S. So L means 0, and what is N? N is this one. Suppose if there is 2S1, then N will be 2. Now it's 1S1, so N is 1. Now if you substitute the value of P and Q, it's 1 in the Laguerre polynomial. So it will be L11x equals to d by dx 1 1 raised to power 1 into L raised 1 into x. So you need to know this value LQX, that is L1x. It will be equal to e raised to power x d by dx e minus x x raised to power 1. So ex will be as it is. Now you will differentiate this term. So differentiation of e minus x is minus e minus x into x plus e minus x will be as it is, then x1 will be differentiated. So what's differentiation of x1? It will be dx by dx. So it turns out to be ex minus e minus x x plus e minus x, because dx by dx is 1. Now you know that Ex into E minus X is 1. So Ex into minus E minus X into X. So it will be minus X plus Ex into E minus X is 1. So it will be minus X plus 1. So the value of LQX is minus X plus 1. Now you have to calculate the value of Laguerre polynomial, that is LPQX. So it will be L11x. It will be equal to the differentiation of L1x. L1x you already calculated the value, that is minus x plus 1. So the differentiation of minus x plus 1 is minus 1. Like dx is 1, so it will be minus 1. Now suppose if q value is 2 and p value is 1. So how you will calculate it? It will be LPQX. This formula you know. So if you will substitute the value of p and q, so basically you have to calculate, you need to calculate L2x. So what's L2x? L2x is Ex d by ds, like double differentiation of E minus x into x cube. So Ex will be as it is. Ex will be as it is. So differentiation of like double differentiation, so d by dx, differentiation of E minus x, it's minus E minus x square is as it is, plus E minus x is as it is, differentiation of x square, it is 2x. Now again you have to differentiate these terms. Now they're basically two terms. So for the first term differentiation, it will be E minus x square plus minus E minus x 2x plus E minus x 2x plus E minus x into 2. Then after solving it, it will be x square minus 4x plus 2. Then this value was for the L2x. Now you have to calculate L12x. So again after differentiating this term, it comes out to be 2x minus 4. So in this manner, you calculate the value of Laguerre polynomials. So that's all for today. Thank you.